closely at the sine curve. The sine of 0 is 0. As the angle increases from 0 to a right angle, the sine increases from 0 to 1. As the angle continues to increase from a right angle to a straight angle, the sine curve drops back to 0, forming a symmetric arch. The arch is symmetric about this line because the circle is symmetric about this diameter. If this is t, this is pi minus t. So the symmetry of the arch can be written as a simple equation. The sine of pi minus t is equal to the sine of t. The two angles t and pi minus t are called supplementary. The sine of an angle is equal to the sine of its supplement. Let's continue examining the sine curve. As the angle increases from pi to 3/2 pi, the sine is negative, and it stays negative until the angle reaches 2 pi. Look at its graph from pi to 2 pi. If you slide it back pi radians, it's just the first arch flipped over. And here's why. If this is t, this is pi plus t. The sine of pi plus t is the negative of sine t. As the point moves counterclockwise around the circle several times, the basic shape is repeated over and over. Any curve obtained by repeating one shape indefinitely is called periodic. If the point moves around the circle in the opposite or clockwise direction, the angle swept out is considered negative. Here's the sine curve plotted along the negative t-axis. The circle is also symmetric with respect to this diameter. If this is t, this is negative t. The sine of negative t is the negative of sine t. This is another axis of symmetry for the circle. But when we reflect the sine curve through this line, we get a new curve. Let's look at this curve. If this angle is t, this one is pi over 2 minus t. The two angles t and pi over 2 minus t are called complementary. The sine of the complement of t lies on our new curve. It is called complementary sine, or cosine. And it's written like this. The cosine comes from flipping the sign about the pi over 4 line. So, on the circle, the cosine is the horizontal x-coordinate of the point, just like the sine was its vertical y-coordinate. In other words, when a point moves on a unit circle through an angle of t radians, its rectangular coordinates are x equals the cosine of t and y equals sine t. Here's another way to get the cosine curve. Start with the sine curve and shift it to the left by pi over 2 radians. If this is t, this is pi over 2 plus t. The cosine of t is also equal to the sine of pi over 2 plus t. So we have two ways to relate the cosine and sine. Cosine t is the sine of pi over 2 plus t, and cosine t is the sine of pi over 2 minus t.